Hey guys, welcome to the video. Today we're going to be working on the Unit 3 practice problems. Almost all of you guys overwhelmingly voted for this. Actually, that's not 100% true. A lot of you guys voted for all of them. I don't have time for that, so we're just going to do practice problems. And that's the longest thing I've given you. So we're actually going to split this up into a couple different videos. This first video here is just going to be the first 2 pages, so it's a little easier to navigate. So if you're looking for a problem that's not on page 1 or 2, try to find one of the other videos. Okay. I want to apologize in advance. I do have the sniffles, so I'm going to be a little nasally, but let's do this. So well, they're not numbered, by the way. So the way I made these practice problems is I went through and I found every problem that was possibly related to Unit 3 at all. And if they weren't on the test or your homework or your quiz already, I put them in here. So as much practice as possible. So we have a graph, and they want to know at -1, is it undefined, increasing, decreasing, vertical tangent, or horizontal tangent? Okay. So for undefined, that means it would be not continuous, right? This is good, it's continuous everywhere. For it to be increasing, the derivative would have to be greater than 0, positive value, right? Because then the slope would be going up. For decreasing, the derivative would have to be negative. For a vertical tangent, straight up and down, okay, that would have to mean that the derivative has a number over 0. And vice versa for a horizontal tangent, that would mean the derivative was actually equal to 0. So we're going to take the derivative and see what's happening here. This is a product rule with a chain rule in there. So that's -2x times x plus 2 to the 1/2. So product rule says first times the derivative of the second. So the derivative of the inside is just 1 times, and then we're going to chain rule the outer portion. So 1/2 x plus 2 to the -1/2. So first times the derivative of the second plus the second, which we're just going to leave alone, times the derivative of the first is -2. Then we clean. 2's cancel. So we get -x. The negative exponent brings it to the bottom. And then I have a -2 out here. Square root x plus 2. And most of you guys know at this point we should probably do a common denominator. Not 100% necessary here, but it's good practice because I'll probably make you do that. Square root times the square root cancels the square root. And then for good measure, we're going to FOIL it out and combine like terms. So that's the derivative. Unfortunately, they're not asking about the derivative. They're asking about the derivative at the point -1. So you can go ahead and plug in -1 to the derivative. So that's 3 minus 4 over root 1, which is just 1. So -1. Since the derivative is negative at that point, that means it's decreasing. All right, so this next question here, this is a limit question, but remember I told you we're done with limits. This is secretly a derivative problem. Okay, remember the limit as h approaches 0 of f of x plus h minus f of x all over h is really just the definition of the derivative of f of x. Okay, so right here is the best way to identify what they're asking for the derivative of. See, f of x minus f of x. So really what they're asking for is the derivative of secant of 2x. Okay. This is a chain rule problem because of the 2x in here. So the derivative of that is 2. The derivative of secant is secant tangent. And make sure whatever's in there stays in there. And that's why it's A. Okay. D is definitely going to be in there because that means that you forgot to do the chain rule. Okay. So that's almost always going to be an option. Make sure you're actually doing chain rule. Okay. The slope of the normal line. Normal means perpendicular. So when you find your slope, you're going to do opposite reciprocal at 4. So this function can be rewritten as to the 1/2. Okay. Take the derivative. This is a chain rule problem. So you start with the derivative of the inner function, which is just going to be 2x. And then we're going to power rule the outer function. So 1/2, leave the inside alone, subtract 1, so -1/2. Okay. Clean it up a little bit. Your 2's cancel. So you have x over square root, because the negative brings it down here, of x squared minus 2. And they want us to evaluate it at 4. So now we just plug in 4. So we get 4 over 4 squared, square root of 4 squared minus 2. So that's 4 over square root of 16 minus 2. That's 4 over root 14. Now remember, they asked us for the perpendicular one. Or, well, they asked us for the normal one, which we know means perpendicular. So opposite reciprocal. So we flip it upside down and make it negative. So that's why your answer is C. All right, this page is just a bunch of product rules and chain rules. Okay, and we've got E and natural log. So reminder that derivative of e to the x is e to the x, and derivative of natural log is 1 over x. Okay, so you'll need that for this page. So this is a product rule. So we got first times the derivative of the second. This is a chain rule because there's a function inside that top part. So it'll be 2e to the 2x plus the second times the derivative of the first. And likely here you're going to have to take out anything matching. So we've got an e to the 2x and e to the 2x. And we've got 2 x's. So x squared e to the 2x will come out. You have an x, or a 2x left here. 2 times x plus 3. All right. Next problem. This is just the chain rule. It is not a product or quotient rule. So I start with the derivative of the inner function. The inner function is really just what's up here. Okay. So that's negative 4x. And then derivative of e to the x is itself. All right, this one's interesting because the derivative of the inside here, so normally that function we would see up top, is actually a product rule. So h prime of x is the first times the derivative of natural log, which is 1 over x. We talked about it over here. So first times the derivative of the second plus the second times the derivative of the first. Okay. So that's the derivative of the inner function times the derivative of the outer function. Okay. And then just clean it up. These x's cancel, so you get 1 plus natural log of x, okay, times e to the x natural log x. This one is a classic product rule. Okay. So we've got the first times the derivative of the second. The derivative of e to the x is e to the x plus the second e to the x times the derivative of the first, just 4x. So then I'm going to go ahead and pull out an e to the x. And probably write this in descending order. for 5 here, we have a natural log with an inner function in here. So this is a double chain rule, actually. So the innermost function is 2 to the x. So I got the derivative of the inside, which is 2. Okay. Next function, e to the 2x plus. Oh, no plus. E to the 2x, because the derivative of 1 is 0, times, and then the derivative of natural log is 1 over x. But there's not just an x in there. It's all of this. Okay. So now you clean it up, you get 2e to the 2x over e to the 2x plus 1. And no, these do not cancel, okay, because you'd have to factor them both out. All right, and this one's a little more straightforward than the last one. Okay. The derivative of the inside is -2, okay, times 1 over x, but in this case, the inner function's here. So it's just -2 over 3 minus 2x. And that was the first 2 pages. Check my next one for pages 3 and 4.